Finding the future value using compound interest. The formula for computing future value using compound interest is A equals P times 1 plus R over M raised to the nth power. Notice that the only expression raised to the nth power is the 1 plus R over M portion of the formula. For this formula, A equals the future value, P is the principal or the amount deposited, R is the interest rate written as a decimal, M is the number of times the amount is compounded per year, T is the time in years, and N equals M times T. So in theory, we could rewrite this formula. Instead of writing the N, we could substitute that with M times T, because N equals M times T, which is the number of times the amount is compounded per year times the number of years it's compounded. In this lesson, we will be going over examples that require us to use the exponent key on our calculator. Different scientific calculators notate the exponent key in different ways. Here are 3 examples. The first calculator shows that the exponent key is an upward facing arrow sign. If we were to use this calculator for exponent operation, we would type in a number, then the exponent key, then the exponent. The middle calculator shows an exponent key of x with a square in the upper right corner. This signifies that we'll type in the number for the x, then we'll type this key, and then we'll type in the exponent, signifying the number that goes in the square. The last calculator has an exponent key of y to the x power. Again, this is the same thing. We would type in our number for y, then the exponent key, and then the exponent. If you're having trouble using your calculator, please research your calculator and then email your professor. They can help you determine what process to take when solving exponent equations using your calculator. Use the formula for computing future value using compound interest to determine the value of an account at the end of 8 years if a principal amount of $16,000 is deposited in an account at an annual interest rate of 3% and the interest is compounded monthly. Okay, this is a long word problem, but really all we're going to do is use this formula for computing future value. So here we have the formula for computing future value. It's A equals P times 1 plus R over M raised to the nth power. In order to use this formula, we need to identify the values that were given and then plug them into the equation. So A is the future value. This is the value that we want to find. So we're just going to write an A in our equation because we don't know that value yet. Now I want to find the value for P. So P is the principal amount. Our word problem says that the principal amount is $16,000. So I'm going to plug in a 16,000 for P. Now I want to find the value for R. R is the interest rate. And remember, if the interest rate is given as a percentage, which it is in this problem, we need to convert it to a decimal before putting it into the formula. So our problem tells us that the interest rate is 3%. To convert a percentage to a decimal, we need to divide by 100. So 3 divided by 100 is 0.03. And we'll put that into our formula. Now that's divided by M. M is the number of times the amount is compounded per year. The problem tells me that the amount is compounded monthly. So we know that there's 12 months in a year, so the number of times the amount is compounded per year is 12. Now I'm going to raise that to the nth power. N is the total number of compounding periods. To find this, we're going to take the value for M, which was 12, and multiply it by T, which is the number of years the amount is compounded. So we'll go back to our problem, and this tells us that we're going to compound the amount for 8 years. So my value for N is 12 times 8. And 12 times 8 is 96. So N is 96. Now I identified all of my values, so I can go ahead and solve this formula. The first step is to look at the parentheses, and we're going to perform the division within the parentheses. So it's this portion right here. So we'll do 0.03 divided by 12. That gives me a value of 0.0025. Now I'm going to bring everything else down so I can keep my problem nice and organized, and so I don't lose any values or any steps. Next thing is I'm going to perform the operation in the parentheses again, and now the operation is addition. So I'm going to add 1 plus 0.0025. When you add those values together, you get 1 plus 0.0025. I'm sorry, 1.0025. And we're going to raise that to the 96th power, and then it's being multiplied by 16,000, and it equals A. Okay, so my next step in the order of operations, my first step was to do everything inside the parentheses. Now my next step is to do the exponents. Remember, here is my order of operations. So this was parentheses, which I already did. Now I need to move on to any exponents in the problem. There is an exponent, so I'm going to do 1.0025 to the 96th power. So you should do this on your calculator. Your calculator should have an exponent key. Some calculators, the exponent key looks like this. Others, it looks like this. And then a lot of calculators actually have a little upward facing arrow, which is a caret key. So that would be the exponent key. So typically you type in your base, which is the 1.0025, the exponent key, and then your exponent, which is 96. When you do that calculation, you get a long decimal of 1.27086847. And you always want to keep the decimals as long as possible while you're working the problem, and then at the end of the problem, you can round. If you round while you're working the problem, you'll have rounding error when you reach your final result. So just wait until the end to round your decimals. Right, now I have A equals 16,000 times our decimal value. So we're going to just multiply those two values together on our calculator, and we'll get an answer of 20,333.89547. And this is what A equals. Now A is our future value, which is a monetary amount. That's what we're going to get after we invest, and it's compounded monthly for 8 years at a 3% interest rate. So this is what we'll get. Now, since it's a monetary value, we're going to round to the nearest cent. That means 2 decimal places. So in order to round to 2 decimal places, we look at the value in the 3rd decimal place, which is a 5. Since the 5 is greater than 4, that means that this value, the one next to it, is going to round up. So the 9 rounds up to a 10, meaning that 8 now rounds up to a 9. So our rounded value is $20,333.90. And that is our final answer. We will type in $20,333.90 into the text box. Notice that there's already a $sign next to the box. Therefore, we only need to type in the value. $20,333.90.